really one of our last sections. We just need to talk about word problems after this, and those aren't going to be a big deal at all. Today, today's kind of a fun day, and they're not bad. They're not. You don't have to think a whole lot about how the word problem's set up. They're really not bad at all. What we want to do today is we want to talk about solving exponential logarithmic. I should say equations, not functions, but I obviously didn't know what I was talking about when I wrote it. And we want to look at this kind of problem. 8 to what power is 162? Well, 8 to the first power is 8. 8 to the second power is, and 8 to the third power is 512. So we're wondering, what is 8 to what power is 162? We know it has to be between 2 and 3, right? So we're going to find out a way to work through that. And it's not like dividing both sides by 8. If the equation looked like this, then yeah, we would divide both sides by 8. But in order to get at that 8, we have to do something else. And what we're going to do is we are going to use our inverse operations of logarithms and exponential functions. And so I've written it all out here. What I do is I have 8 to the x, and I have 162. Well, what I've done is I've taken the log base 8 of both sides. Well, what happens to log base 8 of 8 to the x? Cancel, leaving you with x equals log base 8 of 162. And can we calculate that? Yeah, we learned how to do that yesterday on our calculator. How do you do it? What do I press? Log 162 divided by log of 8. If you hit the natural log key, it'll do the same thing. Natural log of 162 divided by the natural log of 8. You do either one, and you get 2.447. And that's it. That is the primary example that we want to be able to solve today. Any questions on the first one? How do I get rid of a base of e? I do log base e, which is natural log. Natural log base e to the x is equal to natural log of 2. Just take the natural log of both sides. And you can see that what happens is that goes away, leaving it x is equal to, and the natural log of 2, if you type it in your calculator, you get 0.693. Any question there? Going once, twice, thrice. Try the next one on your own. Try C. Go. Okay, what'd you get? Somebody 3 decimal places. What do you got? Real good? Awesome. You get the general idea. Let's look at 2a. E to the 2x minus 3 is equal to 7. Now you have more in the exponent. Looks like it's a little bit more challenging. Really not that big of a deal. We just take the natural log of both sides. When you take the natural log of both sides, the natural log and base e do cancel, and I get 2x minus 3 is equal to, and now I type in the natural log of 7. I get 1.946. I'm going to add 3 to that. I'm going to divide by 2. And I get x is 2.473. Pretty straightforward, huh? Try letter C on your own. Go. Okay, somebody want to give me a result? Be brave. Throw it out there. We all make mistakes. 3.262. Any questions? Somebody want to see me go over it? Are we okay? All right, let's try a more complicated one. Let's look at D. What makes D more complicated? You have, I sure can. Okay. I sure will. Thank you for speaking up. Yeah. Thank you for doing so. Log base 2 of 2 to the 2x minus 1 is equal to the log base 2 of 46. Those cancel, leaving me 2x minus 1 is equal to whatever that is. I'll calculate that by doing log of 46 divided by log of 2. And I get 5.524. Did you get the 5.524? What'd you get? You just did the log of 46. Got to do the log of 46 divided by the log of 2. Better now? Excellent question. Thank you for asking. Okay, there are two different bases. So at this point, we are going to let's see, we'll pick on Willie. Willie, do you want to get rid of the 3 or the 2? You want to get rid of the 3. So what do you want to do to both sides? Log base 3. So Willie says, let's do log base 3 of 3 to the x plus 1. And then he has this internal struggle. Like he's tempted to say, log base, well, wouldn't it be convenient if instead of a 3 it was a 2 over here? But he knows that there's something wrong with that because he was always told that if you do something to one side of an equation, you must do the same thing to the other, correct? And so it would be so nice if we could just do that, wouldn't it? The fact is that you cannot do. So therefore, we must leave it as a 3. And as disgusting as that is, we know that at least it takes care of the left side for an x plus 1. But the right side, we have this very awkward log base 3 of 2 to the 2x minus 3. And it's staring right at us. And unless somebody has an aha moment at this point, we will not be able to complete the problem. Logan. Very good. Give Logan a round of applause. Also, you do not need to raise your hand in this classroom. You just shout out the answer. But thank you for raising your hand. Logan's absolutely right. He's going to take this 2x minus 3, and he's just going to dump it right out front. That way, instead of having the exponent in the numerator, or I'm sorry, instead of having the x in the exponent, the x is a coefficient out front. X plus 1, come on, Gens, pull it together, is equal to 2x minus 3 times log base 3 of 2. Now, I know you may not like that log base 3 of 2, but it's just a numerical value, correct? We could compute that. We just look at our calculator, turn it on, take log base 3 of 2. Log of 2 divided by log of 3, bada bing, bada bam, bada booski, 0.631. X plus 1 equals 2x minus 3 times 0.631. Distribute the 0.631, and I get x plus 1 is equal to 2 times 0.631, 1.262x. Should we make Asher throw them away in the garbage? Should we send him down to Mr. Grossklaus to ask him if he gets special permission to eat in class while nobody else does? A certificate that says, I am more special than anybody else, so therefore I will eat in class. I think next time we should throw it away. Should we give him fair warning? All right, I think he gets the point. All right, here we go. So I distribute through. Now I'm going to go ahead. I'm going to subtract the x. I'm going to add the negative 1.893. I get 2.893 is equal to 0.262x. 2.893 divided by 0.262. And I get x is 11.042. Are there any questions with that example? That's a tougher one, isn't it? You're going to have to do it. It'll be on your assignment. It'll be on your study guide. It will be on your test. You can call me stupid. You can call me bald. You can call me short. You can call me fat. You can call me a bad teacher. You can call me whatever you want. But you cannot say that I don't tell you what's going to be on the test. See, that's why it's nice to have Josie back. She's one of the only ones that'll laugh at my jokes. Try letter E on your own. Go. Try letter E. Compare it to a partner. See if you get it right. This is like test time right now. See what you get. Okay, here we are. You can see we've got x squared minus 4 is 3.109. As you work through that, we subtracted the 6. We divide by -1. Took the log base 5 of both sides. Add the 4 and then square root. You do get two solutions, plus or minus what? 7.109. No. Got to take square root. What do you get? 2 point Satan. Very good. All right, there we go. Cool. All right, how about this? A little bit of insight and aha moment on your part for letter F. I got e to the x and e to the x. Oh, boy. Four over won't work. Excellent idea. Unfortunately, it won't work. Factor. Yeah, that boy Doyle. Yeah. So, because e to the x times e to the x, you add the exponents, right? So x plus x is 2x. That's why you get that. And then two numbers multiply to 4 that add a -5 would be -4, -1. We've just got e to the x minus 4 is equal to 0. And e to the x minus 1 is equal to 0. So e to the x is equal to 4. And e to the x is equal to 1. Now what do I do to solve? Natural log both sides. So natural log of e to the x is equal to natural log of 4. Or x equals whatever that is. 1.386. And then the natural log of 1, hopefully you all know that. That means e to what power is 1? 0. Thank you, Josie. And those are our two answers. We've now covered exponential functions. I would say let us take a 7-minute break, and you can start working on your assignment. And then we'll go to logarithmic functions. Press pause. And so we solved exponential equations. Now let's solve logarithmic equations. And so it says log base 5 of x is equal to 2. Now I know that you could look at this and solve it, but understand the inverse operation that's going to exist here, because this is how I'll teach it. I need to get at the x, so I need to get rid of the log base 5. Here's how we get rid of the log base 5. We create a base of 5. Do you see the original expression, log base 5 of x is equal to 2, but I've created a base of 5? I know that that hurts you to look at it, because you're like, that just seems so foreign. But again, I'll bring you back to this. There was a time where this looked foreign to you as well, right? But you just trusted that those cancel each other out. In the same way, you trusted that those cancel each other out. Well, works out here too. They cancel each other out. It leaves you with x is equal to 5 squared, or 25. So if you ever want to get rid of a logarithm, simply create a base that matches the base of the logarithm. So for letter B, log base 8 of 3x minus 7 is equal to 2. Just drop a base of 8. What happens to the left-hand side? What are you left with? 3x minus 7 is equal to 64. Add the 7, 71. Divide by 3, x is 71/3. I think that's pretty awesome. Try letter D on your own. Go. We're good? All right. Letter E. What do you do first? Subtract the 6. 2. Natural log of x squared minus 2 is equal to 3. Now what? So the natural log of x squared minus 2 is equal to 1.5. How do I get rid of the natural log? Base of e. Create a base of e. They cancel, leaving it x squared minus 2 is equal to e to the 1.5. I don't know what that is. If you do know what it is, good for you. 4.482. I'll add 2, and I'll square root the answer, and I get 2.546. Trying to read the room to see if there's a question. Oh, okay. Thank you for asking. I've never really told you guys that, have I? Okay. There's 2 ways to come across the e in the calculator. Number 1, it's just second natural logarithm, and it will create e with an exponent. Or you can hit the one below pi, second e, then it just creates the number e. If you'd like to take that e and raise it to a power, then you can. So you can either do that one, or you can do that one. You know, I wonder what that is. Doesn't like it, I guess. Who knew? It's kind of fun when there's the letters in math, isn't there? It's like, the Greeks, they didn't call that math. They called it arithmetic. Do you know what the word math means? It comes from the Greek word monthano, which means I understand. So in the eyes of the Greeks, to do mathematics was to truly understand the inner workings of something. There you go. All right, we move along. Log of x minus log of x plus 1 is equal to 2. Oh no, I have 2 logarithms. The world is coming to an end. I shall quit and give up. Or maybe somebody in here has the aha moment and they know what to do. Like any good teacher, I would prepare you to handle this problem. Like maybe something I showed you yesterday. Cully, thank you for saving us. A for the day. Log of x over x plus 1. I make 1 logarithm. Awesome. Now I know how to get rid of the log. I create a base of 10. I love the number 10. Gone. X over x plus 1 is equal to 100. Cross multiply. 100x plus 100 is equal to x. Subtract the 100x, I get 100 is equal to negative 99x divided by negative 99. Isn't that great? I mean, you walked in this class, you had no idea I'd do that kind of a problem, but now you do. Yes, Josie. Can somebody tell Josie, why is it a base of 10? What's the base here? 2. Base here? 10. We just don't write it. We assume it. Base here? E. We don't write it. We just assume it. Better? Great question. Let's try 2 more and call it a day. Shoot, letter C. That looks really tough. It's got that ln thing in it. I don't even know what to do. Multiply. Thank you, Marty. Natural log of, we take x plus 2 times x minus 2. Hey, they're conjugates. Amazing. Middles are going to cancel. You get the x squared minus 4. Love it. Equals 2. Shoot, how do I get rid of natural log? E, isn't E awesome? So handy. X squared minus 4 is equal to E squared. Oh boy, I don't know that. It's like 7.389 maybe? Is it exactly? I taught the class twice today, so I had a pretty good shot at guessing. Add the 4, square root. X is equal to plus or minus 3.567. Time out. I got to show you one last piece that's slightly confusing because the fact is that both the problems we just did are wrong. Like, Mr. Gens, why would you allow us to go down that path? I'll show you. You know what the logarithmic function looks like, right? Looks like that. So, are you allowed to take the logarithm of positive numbers? Yes. How about negative numbers? No. How about 0? No. Domain of a logarithm is going to be from 0 to infinity. The domain is 0 to infinity. So, think about it. If we took these answers and plugged them back in, if you plugged in positive 3, it would be the natural logarithm of, be like 5.375, right? Is that okay? Sure is. Then we have the logarithm of, we plug in 3.37, you're like 1.375. Is that okay? Yep. But think about the negative one. If we plug the negative 1 in, that'll produce the natural logarithm of a negative 1 point something, right? That's problematic. So the fact is that only 3.375 works. Look at your previous one. Negative 100 over 99. If you plug that back in, you get the logarithm of a negative. You can't have that. So therefore, no soul. Now, in 4th hour, when I say no soul, they go nuts. This is true. It's sometimes slightly annoying. Sorry, 4th hour, if you heard that. But why do they go nuts over no soul and you guys don't? Didn't you all have the same teacher last year? So what's the deal? Okay. Do you remember them going crazy over no soul? Was this a thing in Hanson's class? Okay, you went crazy over. Where's the enthusiasm now, Alexis? Okay, all right, very good. I don't know. Sorry, I lost you. All right, last example. You know what? You try it. See what you come up with. Go. All right, awesome. Pause. And you guys, the reason why I do is you're more likely to learn about the problem if you actually invest yourself in it first and then see where you go wrong. I mean, you just learn better as opposed to copying down everything I say. So the first thing we do, we're going to actually move the 2 up there. So log base 3 of 4x plus log base 3 of x squared is equal to 3. And now I can write these as one logarithm, right? I can write it as log base 3 of 4x cubed is equal to 3. So the key is to get this 4x cubed. Now I have a single logarithm. That's an ugly 3, wasn't it? I create a base of 3 to get 4x cubed is equal to 27. Now it's a piece of cake upside down. Take the 27, divide it by 4, and then take the cubed root of that. We got number 4 here. Cubed root of the answer is 1.890. Sweet. Good. Good work, folks. We got 5 more minutes. Which it, actually, if you think about it, you guys got 5 minutes at the end of class. You had 8 minutes in the middle of class. But fourth hour, like they literally didn't get their assignment until after the bell went, right? Yeah, it's amazing. But they're a chatty bunch. Chatty Cathy's.